Aloha, champions, and welcome back. It's another Tuesday and another science lesson. Hopefully over this past weekend, you've had a great opportunity to put science into action and to see how energy can transfer from one moving object to another moving object. So, in our continuation of energy causing change, the ability to cause change, and applying that with our Rube Goldberg machines or our chain reactions, we are moving into chapter 3 of our textbook. So, without further ado, Mr. Chambers will read through chapter 3 and you will respond accordingly with 5 to 10 questions in Google Classroom. I know these videos seem a little bit longer than normal, but I want us to understand science. I want us to be connected with informational text, and this is the easiest way that I found because I can't send the PDF to everybody. It's a lot of pages to scroll through. So hopefully this format works for you. I know some of the questions may seem a little challenging on some of our Google Forms things. These are not to trip you up. They're not designed to frustrate you or upset you because you're not getting everything right. And remember, if you're typing in your answer, it takes Mr. Chambers a few days to check those answers, to see and correct those, so you're doing fine. Every opportunity, even if it says quiz on it, it's not a quiz. It's just a learning opportunity. I try to put in enough comments so that you learn from your mistakes so that we can continue moving forward and growing as scholars, okay? But without further ado, we're on chapter 3. Energy and speed are related. Energy and speed are related. So, like we've talked about in the previous 2 chapters, there is a big question, a question we have to try to answer. We might not have the perfect answer, but we can start thinking about this. And maybe this big question leads to more smaller questions, because that's what scientists do. They ask questions. They want to learn, like a scholar. So our big question for chapter 3 is, how are energy and speed related? How are energy and speed related? Well, with this chapter, we do have a new vocabulary term, and that term is speed. So speed is a measurement of the distance an object travels over an amount of time. So you might have been driving in your car with your parents, and you might notice the odometer, or the speedometer, I should say. The speedometer is going up, and it's saying, hey, we're going 45 miles per hour. Well, if you traveled in your car going that same rate, you would travel 45 miles within that hour. So it is a relation of the distance you travel and the time it takes you to get there. That is your speed or your velocity, okay? When you get to higher grade levels, they change the term speed to velocity. They mean one and the same thing. It is the amount of distance you've covered in a certain amount of time. The shorter that time is, the faster you are going, okay? So somehow, energy, the ability to cause change, is related to speed, the amount of time it takes for us to cover a certain amount of distance. So let's get into this chapter, shall we? Imagine catching a ball in your hand. If the ball is thrown gently, it doesn't hit your hand very hard. But if that same ball is hurled with strength, it hits your hand and stings, and ouch! It's a great use of an onomatopoeia, Mr. Chambers' favorite word. And yes, every time I see onomatopoeia, I am going to say that. But ouch! Why does it sting? One reason is because of the greater speed at which the ball was moving. Speed is a measure of the distance an object travels during an amount of time. One unit for measuring speed is miles per hour, or mph. Many countries 194 out of the 197, use kilometers per hour, kph, as a common unit for speed. When you ride in a car that is traveling 50 miles per hour, or about 80 kilometers per hour, that means you'll have a distance of 50 miles, or 80 kilometers, in 1 hour if the car's speed remains constant. If there's no stopping, no traffic, you can travel that far over the course of an hour. So down here we have this picture of this baseball player throwing the baseball, and the caption for this says, "Some pitchers can throw a baseball at speeds faster than 100 miles per hour. Players wear heavy gloves to protect their hands." Because 100 miles per hour, that's got a lot of energy, kinetic energy, that could hit and really hurt. All right, next page. Greater speed is related to greater energy. Objects with greater energy cause greater changes. Remember that energy is the ability to cause change. When you catch a ball, the motion energy from the ball, or the kinetic energy, causes a change when it hits your hand, which will cause a greater change. A ball moving slowly, or the same ball moving quickly. So, if a ball is being thrown at us and we catch it, do we want a softball or do we want a fastball? Which one causes the greater change in the scenario? The ball moving slowly causes little change. Your hand might feel only a gentle tap. Compared to a slow-moving ball, the same ball moving quickly causes greater change when you catch it. Your hand moves backward and you may feel a sting. Whap! Again, great onomatopoeia. We even have the word bubble to say, hey, look at me, I'm onomatopoeia. It's great. It's right there. Whap! Greater changes the movement of your hand and the stinging sensation show that an object's speed is related to its energy of motion. The faster the ball is moving, the greater its motion energy. So if the same ball is thrown twice, the one with the faster speed will have the greater energy. But how do you know? Well, we know because there are greater changes caused by the faster moving ball when you catch it. It hurts more. It sounds louder. Things that we can observe with sensory details to tell us, yes, this is moving faster. The faster it moves, the more energy it has. All right, but sometimes balls aren't thrown. Sometimes balls are rolled, and you might have used a rolling ball in your Rube Goldberg machine that you came up with over the weekend. The faster a ball rolls, the more energy that it has. Objects rolling downhill or down a ramp pick up more speed on steeper slopes. Flat doesn't roll very fast. Steep, it rolls, okay? Imagine a ball rolling down a ramp. It will have greater energy of motion, kinetic energy, after rolling down a steep ramp than it will have it rolling down a lower ramp of the same length. But how do we know that the fast-moving ball has more energy than the same ball when it is rolling slowly? If we let the ball hit a bucket at the bottom of the ramp, the slower-moving ball from the lower ramp will not move the bucket very far. The faster-moving ball from the steeper ramp will knock the bucket over. So here we have a shallow ramp and a steeper ramp, and this knocks the bucket over, the shallow one does not. The change to the bucket's position is greater when the ball was moving with more speed. This means the motion energy of the ball was greater when the ball was moving faster. The faster it is, the more kinetic energy that it has. So we've talked about throwing a ball, rolling a ball. What about bouncing a ball? Bouncing a ball shows how energy and speed are related. You can provide evidence to show that an object causes greater change when it is moving quickly compared to the same object when it is moving slowly. Bounce a ball. First, gently drop the ball. What changes? The ball bounces, but not very high, maybe up to your knees, and it might make a little noise. Boink. Onomatopoeia is the best, and I will say this every time. Then throw the ball hard against the ground. What changes compared to when you gently dropped the ball? The ball bounces higher, maybe as high as your head, and it makes a louder noise. Boing! Onomatopoeia. Now think about throwing the ball against the ground with all your strength, as fast as you can. What changes compared to the other times that you threw the ball down? It bounces even higher, way above your head, and it makes even louder noise. Boing! Onomatopoeia is my favorite, and it makes science so much more fun. It makes everything more fun when you see big, old words like this. It's my favorite word in the English language, and I just love to see onomatopoeia in action. The motion energy of a fast-moving ball is greater when the same ball moves slowly. But how do we know? You know because you can compare what changes when the ball hits the ground and bounces, when the ball is moving at a faster speed. You know it has greater energy of motion, kinetic energy, because you can see and hear greater changes. You see a higher bounce and hear a louder sound. Greater change is evidence of greater energy. So you have sound energy. You have movement energy. You see the energy. If something is moving faster, it has more energy. Okay? A ball bounced softly will result in less change than one that is bounced hard. And that will wrap it up for chapter 3. So, thinking about fast-moving objects and how much energy they have, you will have about 5 to 10 questions to answer in Google Forms about this chapter. So, hopefully you've had time to take notes, you're thinking. And don't be discouraged if the questions seem difficult. They are learning opportunities for you. Some of the things I know I didn't cover in this chapter, but I'm looking to see us apply our general knowledge of this and to read through context clues within the Google Forms in order for us to do better. And if you take time to type out an answer, if it's a short answer, you don't get the immediate response back because it takes Mr. Chambers some time to go through and check that. And I'm trying my best to give you some more specific feedback with those things. So don't worry if it says you scored low. If you have quite a bit of questions that you needed to type out, every question you type out is worth more points than the ones where you just multiple choice, but it takes Mr. Chambers longer to answer. So hopefully that sets you off on the right path. Hopefully you have fun bouncing, throwing, or rolling balls to test the science into practice. Maybe if you think to yourself, hey, I want to go back and redo parts of my Rube Goldberg machine, knowing that I can speed up the balls that are rolling and it will cause bigger collisions, which means I can destroy more stuff. And that is where science gets really fun. So, stay awesome, and I will see you in our next science video. Bye.